Okay, so our chapter discussion today is about monoprotic and polyprotic acid-base titration. So for our session today, we will cover the monoprotic topic lang na. Okay, so this is the course outline. So let's have an overview of the titration, although this will be discussed in the lecture. Okay, and then we will walk through some basic calculations which we already know. No? So alam nyo na yung mga calculations necessary for titration. Review lang natin sila ulit. And then after that, later, we will end the session by discussing monoprotic titrations. So, monoprotic titration, apat yan actually. Strong acid, strong base, strong base, strong acid, weak acid, strong base, weak base, strong acid. Okay, so those are the four different types of monoprotic titration. And just as I said earlier, as long as you know your conditions, malalaman mo kung anong equations yung kailangan mo gamitin. Okay? So ano lang to, may step na talaga na susundin. Ang gagawin nyo na lang is alamin kung ano yung susundin mo. Okay? So it requires our knowledge of identifying strong acids, strong base, weak acid, weak base. Okay? Basta alam mo kung anong chemical species meron ka, madali na lang to. Okay? So we will cover these three subtopics today and the other three by next meeting. Okay. So let's have an overview of the titration. I don't know if this has been discussed in your lecture, pero daanan na rin natin. So when we say titration, titration is a form of volumetric analysis. No? So when we say volumetric analysis, it involves liquids, no? Measurement of liquids used in chemical reaction. Okay, so this is a volumetric analysis in which substances react to completion, often observed using chemical indicators. Okay, so ito yung mga nakikita nyo sa typical chem post, no? Mga post sa Facebook. Pag may nakita kayong mahabang tube, alam nyo na kung ano tawag dyan, that's called a burette. And you have this Erlenmeyer flask. Ginagawa doon, the liquid inside the burette is slowly transferred dropwise into the Erlenmeyer flask. Then, mapapansin nyo, magbabago yung color ng liquid sa Erlenmeyer flask. That process is called a titration process. No? Kung saan yung liquid dito sa burette, you react it with the liquid in the Erlenmeyer flask. And as they react together, mayroong change sa color tayong ma-observe with the help of the chemical indicators. Okay. Um, one of the form of titration is called the neutralization titration. So when you say neutralization titration, these are titration processes that involves neutralization reaction. So ibig sabihin, meron tayong acid and base reacting, no, sa titration process. Okay? Maraming uri kasi ng titration. We have the redox titration, complexometric titration, etc. titration. No? So, pero hindi na natin di-discuss yun kasi hindi naman kayo BS Chem. So, for now, let's focus on the neutralization titration. Okay? So, again, to summarize, we say that titration is a volumetric analysis in which yung dalawang liquids, yung components nun, you react them together into completion. And during that process, there will be an associated color change, no, with the help of the chemical indicator. Magbabago yung liquid sa loob nitong Erlenmeyer flask, no, as the reaction is happening. Okay. And for our session today, we will cover only neutralization reaction, okay, or neutralization titration. Okay, from Gen Chem, you know that neutralization titration, yung meaning ng neutralization is that yung acid nire-react mo sa base to form neutral compounds. Okay, so yan. So in titration, ito yung ginagawa, increments of reagent solution or the titrant are added. Ibig sabihin nun, yung liquids na titrant, yun yung nilalagay sa Erlenmeyer flask that contains the analyte. Okay? So, pagsahaluin mo silang dalawa, and eventually, the color will change, no? And once na nagbago yung kulay ng solution, that means that the reaction is complete. Okay? So once the desired color is achieved, no? Tapos na yung reaction mo. Okay? So these are some terminologies that we will encounter. So kung napanood nyo na yung videos na share ko sa inyo last time, yun, magiging familiar na kayo with those terms. No? When we say analyte, alam na natin to, these are substances that are unknown. No? So ito yung mga substance na ina-analyze mo, kaya nga analyte. No? Okay. So nasan yung analyte natin? Yung analyte yung nasa Erlenmeyer flask. Okay? So, analytes are those in the Erlenmeyer flask. No? Sila yung inaalam mo yung amounts. Okay? When you say titrant, we also call this the standard. No? Titrant or standard, these are substances with known concentration. Okay? So, bali ang nangyayari sa titration, we use the titrant to know the analyte. Okay? Alam natin yung identity nito. Alam natin yung kanyang molarity. Alam natin yung volume kasi syempre may volume indicator yung burette. So with all those three information, yung identity ng substance, volume ng substance, and the molarity of the substance, we can infer about the analyte. No? Pwede natin malaman kung ano tong analyte na to with the info given by the titrant. Okay? So depende kung gaano karaming titrant na ubos, it will tell us gaano karaming analyte yung meron doon. Okay? Mamaya makikita niyo yan. No? Then, sabi kanina, di ba, titration requires a chemical indicator. So when you say indicator, these are substances that produces color at certain pH. No? So, kunwari, nag-pH 7 na, bigla siya magiging light pink. No? O kunwari, biglang pH 9, purple na siya. Okay. So, yun yung mga indicators na. Okay. Kasi ang problem, kapag may dalawa kang liquid na pinaghalo, walang color agad yon. Kailangan ilagay mo pa yung indicator para magbago yung kulay ng solution. Okay. So, kung familiar kayo sa high school experiment, yung red cabbage, di ba, ina-extract yung molecules doon. Yung red cabbage, papakuluan mo. Then, yung katas ng red cabbage, ilalagay mo sa acid or basic solutions, magbabago kulay. Tawag doon ay indicator. Okay. So, pwede siya gamitin sa titration actually. Okay. So, yan. Mali-discuss din natin later on kung ano yung mga types of chemical indicators. And then, ito naman, equivalence point. When we say equivalence point, this is a point wherein an equivalence is achieved. Na, di ba? Pinag-iisipan. Hindi. Ang meaning lang niyan is, ito yung point at which the neutralization reaction is complete. Pag sinabing equivalence, ibig sabihin yan, stoichiometrically, equal na yung moles ng substances natin. Okay. So, yan. That is the point at which the reaction is complete. Equivalence point. However, yung makikita natin, di ba kunwari nag-color change na yung indicator, ang ma-observe natin ay yung endpoint. And yung endpoint is not necessarily the equivalence point. Okay? So, bakit? No? Kasi ganito. Ang endpoint yun yung estimate lang. Okay? So, estimate position siya relative to the equivalence point. No? So, ibig sabihin, hindi talaga yun yung equivalence point. No? Yung endpoint, yun lang yung time kung saan magkakaroon ng color change. Pero that color change is just an estimate of the equivalence point. No? So, ibig sabihin nun, pag na-reach mo yung endpoint, medyo malapit na yun sa equivalence point. Okay? So, kaya minsan ini-interchange na lang namin to. Okay? Pero take note that yung endpoint, malalaman mo lang yan kapag may color change na nangyari. Pero ang equivalence point, ito yung stoichiometry. Ito yung calculation. Ito yung experimental. Okay? So, ganun. At again, ang equivalence point, stoichiometry calculation yan. Ang endpoint, nalalaman to by experiment. Okay? And an endpoint is an estimate of the equivalence point. Okay? So, yan. So, yun lang yung mga terms, no? Mamaya may interchange natin yan later on, no? Kita nyo kung paano gamitin yan. Okay? So, before we start, no, I want you to watch this short video muna. So, I included the link there. Okay. So, let's watch this video muna about how to set up titration. Okay? How to do titration reactions. Okay? Teka lang, hindi ko lang alam kung naririnig niyo eh. Alam ko yung pusa, naririnig niyo. Okay. Lakasan ko na lang yung audio. Okay, so this is a video about titration process. Then later on, discuss ko yung mga nangyari. Okay. Mahirap ba kayong marinig? Wait lang ha. Summarize ko na lang. Wait lang. Hindi pala pumapasok dyan sa inyo yung audio. Anyway, so let me summarize the process na lang. So napanood nyo naman yung video, no? So basically, sabi dyan is yung titration. Okay. So yung titration, it requires the known apparatus na ginagamit natin. Yun na-discuss natin on chapter 0. Okay, so we need burette to contain the titrant. And of course, to handle the burette, kailangan may burette clamp tayo and the ring stand. Okay? Then, mapapansin natin that other apparatus ay needed then, such as volumetric pipette and pipette bulb in order to transfer liquids. No? Okay, kailanganin din natin ng beakers or Erlenmeyer flask, no? Which will contain the analyte. Okay. Then, yun. So, itong part ng video na to, panoorin nyo na lang uli after the session. Okay. So, itong part ng video na to, sinasabi dito that pag nilagay mo na yung titrant, you make sure na wala dapat air bubbles. So, na-discuss natin yun din dati. Okay? Bakit kailangan walang air bubble? Kasi may volume yung air bubble, no? And it will interfere with your measurements. So, kailangan liquid lang lahat yan. Kailangan walang air bubbles. Okay? Okay. So, yan. Pag wala na yung air bubbles, then you can start titration. No? So, kailangan, before you start, i-open mo yung burette. Okay? So, i-open mo yung burette para yung liquid mag-pass through. Okay? To ensure na walang bubble din dito sa nozzle. Okay? So, once na wala ng bubbles sa lahat na yan, pwede ka na mag-titration. Okay? So, sabi dito, kailangan mo daw ng reading card. No? Kailangan talaga ng reading card. Although, ginagawa namin minsan sa lab is kinakamay na lang namin yan. Okay? So, you will put your hand against the back of the burette so you can clearly see where the lower meniscus is. No? Sabi dyan, you read the bottom of the meniscus, lower meniscus tayo parate when reading volumes. Okay? And then after nun, you record the initial volume. And then after the titration, di ba, mapapansin ko dito, nagbabago yung color. Ayan. So, ganyan yung nangyayari sa titration. Kaya nakaka-enjoy ito. No? Although nakakainis din. Okay. So, gagawin mo, you will slowly add the titrant. Okay. 2 hands yung gamit natin dyan. So, the first hand will adjust the stopcock. Okay. Yung stopcock, yun yung valve, no? Nitong burette. So, slowly ina-adjust yan. And then the other hand will swirl. Okay. So, it is advisable na ikaw gumawa niyang dalawang yan. Okay. Kasi kapag pinagawa mo yan sa classmate mo, kunwari yung classmate mo yung nag-a-adjust nito, tapos ikaw nag-swirl, hindi kayo coordinated masyado. Okay. So, kailangan isang tao yung gagawa nitong dalawa. Okay. So, as you can see, you need to swirl the solution kasi mapapansin nyo yung pink color biglang nagdi-disappear, no? The reason is that at this point of the solution, dito sa part ng solution, the reaction is complete. However, on the other parts, hindi complete yung solution. So in order to spread out the ions, you have to swirl the solution. Okay? And kailangan ini-swirl mo yung solution para mag-spread out yung ions. Okay? Then once na lahat ng ions ay nag-react na, yung color ng solution ay magbabago lahat, no? Magbabago na siya kahit i-swirl mo pa. Okay. Okay. So yan. So ito yung first trial. Ginawa niya sa first trial ay excess titrant. Ang kailangan kasi na color dito ay pink, no? Ito ay purple na to eh. So ginawa niya, sinobrahan niya muna yung titrant in order to see na kung ano yung pwedeng ano yung kanyang ideal color, no? So, ganun kasi muna, no? Kailangan i-push mo muna lahat ng liquid until maging fully pink siya or maging fully purple. Then from that, you can estimate kung gaano ka pink yung kailangan mong pink, no? So, gaano nga ba ka pink yung kailangan na pink? Ganito lang po. Itong nasa left side. So, ito yung sobra kanina. Pero ang kailangan mo i-achieve ay ito. Very faint pink. Okay? So, mahirap kasi ito sabihin in online setting, no? Pero in face-to-face, mas ma-appreciate nyo siya yung pink na color dito. Pero the idea is ganun nga. So, yung first trial mo, i-overshoot mo lang. Gawin mo lang siyang purple. Then from that, you can estimate at what volume kaya ma-achieve itong faint pink. No? Yung second trial mo, very slow na yung addition. Okay? Until ma-achieve mo yung color na to. Ayun lang naman yung sinasabi ng video na yan. Okay. So basically, balik ulit tayo sa PowerPoint. So basically, this pink color is needed. No? Itong faint pink color. Okay. So ang ginagawa lang kanina is in-overshoot niya para maging purple to estimate kung anong volume yun mag-faint pink. Sabi niya dun sa video, magma-minus 5 ml siya. Okay. But however, for our online setup, no, hindi na natin siya magagawa talaga. So, ang mga ibibigay natin volume ay yung exact volumes na ng endpoint. Okay? So, hindi na natin kailangan mag-estimate dito. Okay? So, yun lang. So, I wish you to, I hope you watch the video pa rin after the session. Ito naman yung link. No? Okay. Para mas makita nyo yung kwento ni Kuya. Okay? So, let's proceed with our discussion. So, after obtaining the data from the experiment, no, ang kukunin mo lang naman data doon is the molarity of your titrant and the volume of analyte and the volume of titrant. No? So, from those three information, you can now do titration calculation. Okay. So, ito yung sinabi ko dito, notes ko dito. Sabi ko dito is that titration calculations, madali lang yan. As long as you know what are the chemical species in your solution. Also, it is necessary if alam mo yung Henderson-Hasselbach equation. Okay? Alam mo dapat na in the presence of a weak acid and its conjugate base or a weak base and its conjugate acid, in the presence of those species, kailangan mo gamitin yung Henderson-Hasselbach equation. Okay? And then, when you add acid sa inyong analyte, yung moles ng base ay mababawasan. And kapag nag-add ka naman ng base sa analyte, yung moles ng acid doon ay mababawasan. Okay? Because the substances are reacting to one another. So, pag naglagay ka ng acid sa base, mababawasan yung base. Pag pag nagdagdag ka ng base sa acid, mababawasan yung acid. Paano mo isosolve yun? Using their moles, no? Using the number of moles. Okay? Paano nga ba kunin yung moles, no? Ano lang 'yon? Molarity times volume, 'di ba? Okay. So kaya nga sabi ko kailangan mo lang ng molarity and volume, then you can do titration calculation na. Okay? So ito lang yung mga notes natin. In addition of two liquids, titrant and analyte, magbabago yung concentration ng substance because of the dilution. Okay? So, pag pinagsama mo yung analyte and titrant, lalaki yung volume and as a result, madidilute yung molarities nila. So, kailangan mo gamitin din yung dilution equation. And then lastly, knowledge of equilibrium calculation will be helpful in some problems, no? Especially for those with acid-base pair, no? Weak acid conjugate base or weak base conjugate acid pair. Okay? So, yun lang. Ito lang yung mga notes ko para sa inyo. Basically, alam nyo na to kasi marunong na kayo mag-Henderson-Hasselbach. Okay? So, ibig sabihin, kaya na mag-titration calculation. Marunong na rin kayo mag-solve ng moles, no? Bakit? No? Kasi yun yung chapter 1 natin, solution. How do you solve for moles? You multiply molarity and the volume. Okay? Kapag solid yan, edi ano yan? mass over, ano, moles is mass over molar mass, di ba? Okay. So, yun. So, alam nyo na mag-compute din ng moles. So, basically, kayang-kaya nyo na to. Okay. And, pag sabi ko nga dito, pag nagdagdag ka ng liquids, nadidilute yung concentrations nila because the volume increases. So, alam nyo na kung paano gumamit din ng dilution equation. So, wala tayong magiging problema dyan. And then, lastly, equilibrium calculation ay kailangan. Okay? In some problems. Okay. However, yung equilibrium calculation, sinimplify na lang dito. Okay. So, ito yung key equations that we will need to use. Itong first equation na to, this is at equivalence point. This is the condition at equivalence point. It says that the moles of titrant is equal to the mole of analyte at equivalence point. Okay? How do you solve for the moles of titrant? That's the molarity of titrant, volume of titrant, times its coefficient sa balance equation. Okay? So, yan yung ano. Yan yung way to solve the moles of titrant. Molarity of titrant, volume of titrant, times its coefficient sa balance equation. How to solve for the moles of analyte? That is the molarity of analyte times the volume of analyte times its stoichiometric factor or the stoichiometric coefficient. Okay? So, basically, basta alam nyo to, okay na kayo. Okay? So, mole titrant equals mole analyte. Okay? So, this is the condition at equivalence point. No? Okay, so how do you solve for the moles? Molarity times volume times the coefficient sa balance equation. For monoprotic acid base, 1 lang yung coefficient. Okay. Next one, we have the dilution calculations. You know this already. M1V1 equals MFVF. No? Okay, so yan. Yan yung dilution calculation. Equilibrium calculation. Ang kailangan natin dito ay ito, yung KA/KB equals 1 times 10 raised to negative 14 or KW. So, kasi later on, we will convert KA to KB or KB to KA and etc. Okay. So, kailangan alam nyo to. I'm sure alam nyo yan. Then, alam nyo rin dapat yung square root of tsaka o kaya square root of CBKB. Okay. So, saan ginagamit to? Pag gusto mo alamin yung initial pH ng solution. Okay? So, yan. Or yung initial concentration ng inyong substances. Di ba ginamit natin to sa equilibrium? Okay? So, ibig sabihin, alam nyo na to gamitin. And then lastly, buffer calculation. Ito yung Henderson-Hasselbach equation. Okay? So, kailan gagamitin tong Henderson-Hasselbach equation? When you have acid and its conjugate base. No? O kaya may base ka and the conjugate acid present in your solution. Okay? So, all these 4 equations will help us in titration calculations. Okay? So, lahat yan magagamit natin sa titration calculation. So, alam nyo na to. Gen Chem pa lang, ginagawa nyo na yan nung senior high school. Dilution, alam na natin yan. Chapter 1 yan. Equilibrium, nagsawa na kayo dyan last chapter. And then lastly, buffer calculation. Na-discuss na din to last chapter. So basically, pagsasama-samahin lang natin lahat ng knowledge last time in order to do titration calculation. Okay? So, yan. Let's proceed na. So, let's start with the monoprotic acid-base titration. So, when we say monoprotic, ibig sabihin nun, isang acid lang or isang base. Okay? So, that means the ratio of analyte and titrant is 1 to 1. Okay? So, that means yung stoichiometric factors nila ay 1 lang. So, this can be reduced to MT, VT equals MA, VA. Okay? Bakit naging reduced to that? Kasi ang kanilang ratio ay 1 to 1. Okay? Isang acid, isang base ang equivalent. Okay? Kaya nga sabi natin monoprotic, no? Isa-isa lang yung nagre-react. Okay? So monoprotic titrations can be classified into actually 4 categories yan, depending on which is the analyte and which is the titrant. Okay? So pwedeng strong acid, strong base titration yan, or strong base, strong acid titration. So kapag strong acid and strong base, that is governed by stoichiometry and dilution calculation. Bakit? Kasi the reaction is complete. So kapag yung reaction mo ay complete, stoic yung susundin mo. However, kapag yan ay weak acid or weak base, kailangan mo na gumamit ng equilibrium. Okay? So again, kapag strong acid, strong base, stoic lang yan. Madali lang siya kasi stoic lang. However, when you have weak acid or weak base na, dun na tayo gagamit ng equilibrium. Okay? So dito mo na gagamitin yung square root of Chaka, yung Henderson-Hasselbach equation. Okay? So yan. So take note of this. Kasi basta alam niyo yung inyong analyte at inyong titrant, yun. Madali na lang. Okay? So again, kapag strong acid or strong base ang meron tayo, stoic yung susundin natin na equation. However, kapag meron tayong weak acid or weak base, ang gagamitin nating equation ay yung equilibrium equations. Okay? So, yan. So, let's start with the strong acid, strong base titration. Okay. So, monoprotic strong acid, strong base titration or SASB titration refers to titration whose strong acids are analytes, okay? And the strong bases are the titrants, okay? So, ano sabi dito? Pag sinabi kong SASB, strong acid, strong base, meaning nun, yung acid ay yung analyte and yung base ay yung titrant, okay? So, let's say strong acid, HCl. Tapos yung, ano mo, strong base mo ay sodium hydroxide, okay? So, itong reaction na to, strong acid, strong base titration yan. Okay? So, yan. When you titrate strong acid and strong base, there are 4 stages no, in this process. May 4 na stage sa process na to. Okay? And for each stages, merong corresponding equation na gagamitin natin. Okay? So, sa titration, 4 yung stages na yan for strong acid, strong base. We have the initial, pre-equivalence point, equivalence point, and the post-equivalence point. When you say initial, ibig sabihin nun, wala ka pang dinadagdag na titrant. Wala ka pang dinadagdag na base. Okay? Initial nga eh. Wala ka pang dinadagdag na kahit ano sa analyte mo. So that means the species present in your Erlenmeyer flask is just water and the acid. Okay? So, yan ha. Pag initial, ibig sabihin nun, volume of titrant equals 0. Wala ka pang dinadagdag na titrant. Okay? So, ibig sabihin, ang species present sa solution ay H2O and yung acid. Yun lang. How do you compute for the pH? Okay? So, the pH can be calculated from the concentration of acid present in your analyte. Okay? So, yan. Next one, pre-equivalence point. Ano nangyayari sa pre-equivalence point? This is a point where you start adding titrant na sa analyte mo. Nagpapatak-patak ka na ng titrant sa analyte. So kung makikita nyo sa video kanina, dun na yung nagiging pink tas biglang nawawala yung pink. So pag nagpatak ka uli, magiging pink tas mawawala uli. Okay? Yun yung pre-equivalence point. Okay? So at pre-equivalence point, ano yung mga species present? No? So the species present at pre-equivalence point are water. Siyempre, may water talaga dyan. And then you have the acid, pero sabi ko dito, less. Bakit less? Kasi, pag nagdagdag ka ng base, ano nangyayari sa acid? Nagre-react sila to form the salt. Okay? So, ibig sabihin niya, mababawasan yung acid mo talaga. And you have the salt na. Okay? So ito yung mga species na present sa atin. So how do you calculate for the pH, no? The concentration of the acid can be calculated as this. Ito yung equation. Interpret natin ano meaning nito. Okay. So MAVA, yan yung initial molarity and volume ng analyte. Okay? Okay. So yun yung gagamitin mo rin dito. So initial molarity and volume of analyte minus yung dinagdag mong titrant. Okay? So in this part, you have the moles of your acid initially minus the moles of titrant added. Okay? Bakit kailangan i-minus? Kasi sabi ko nga kanina, 'di ba? When you add base sa acid, nababawasan yung acid. Ito 'yon in equation. Moles ng acid minus moles ng base. Okay? Kasi nababawasan yung acid. Okay? So kaya ito yung formula niya. MAVA minus MTVT. Moles acid minus moles base, no? So yan, kasi nababawasan nga. Divided by the volume total. O ano namang ganap nitong divided by volume total? Ito naman yung dilution. Okay? 'Di ba sinabi ko kanina, pag pinagdagdag mo yung acid, yung analyte and yung titrant, dumadami yung volume. Ibig sabihin na dilute yung solution. So itong equation na to, it accounts for the decrease in the moles of acid and the dilution of the acid. Okay? So dalawa yung target ng equation na to. Yung decrease sa mole ng acid and the dilution of the acid. Okay? Ayan na. So yan. So yun yung ganap ng equation na to. Again, MAVA minus MTVT, ano meaning nun? Moles acid minus moles base. Okay? Kasi nababawasan na yung acid natin, nagdadagdag na tayo ng base. Divided by volume total in order to account for the dilution. Kasi nagdadagdag tayo ng volume pag dinadagdag yung titrant. Okay? So this is the equation that is needed, no, when solving at pre-equivalence pH. No? Third stage ay equivalence point. Ano yung equivalence point? This is a stage wherein all the acids has been reacted with base to form the salt. Ibig sabihin, wala na tayong acid, no? Wala na tayong acid. Ang natira na lang ay yung salt form nun. Okay? So, of the two species, sino yung nagko-contribute sa pH? E di yung water na lang. Okay? Wala naman pa kayong salt eh. Yung water na lang yung nagko-contribute sa pH. Okay? The water will self-ionize, no? And that will give us a pH equal to 7. Okay? Or the concentration of H plus is equal to the square root of Kw. Okay? So, itong water na lang yung reason bakit meron tayong pH reading. Kasi nagsa-self-ionize siya. Wala na tayong acid, no? So, water na lang talaga yung dahilan kung bakit may pH. And the pH of water is square root of Kw or 7. Okay. So, yun yung pre-equivalence point. Nawala na yung acid. Okay? Then, after nun, kapag sumobra ka, pag lumagpas ka sa equivalence point, post-equivalence point na. Ito yung super pink kanina. Post-equivalence point. At post-equivalence point, what happens here is that you have water, you have the salt, and the excess base, yung sobrang base, no? Mga sobrang titrant na nadagdag mo. So, how do we calculate for the pH of the solution? Okay? So, since base yung magko-contribute sa pH, so we solve for OH equals to MTVT minus MAVA divided by V total. Baliktad siya dito. Okay? Mapansin nyo, pinagbaliktad lang natin. Ito yung pre-equivalence. Ito yung post-equivalence. Bakit? Kasi at pre-equivalence, meron tayong acid. At post-equivalence, meron tayong base. Okay? So, kung gusto mo malaman yung acid, mole acid minus mole base divided by total volume yon. Kung gusto mo malaman kung gaano kasobra naman yung base at post-equivalence point, that is mole base minus mole acid divided by total volume. Okay? So, ganun lang. Pinagbaliktad mo lang yung case dito. Dito, maraming acid. Dito, maraming base. So, basically, you just flip the equation. Okay. So, yun lang. As long as you know the stages, may corresponding equation doon that will help you to solve the problem. Okay. So, if you graph the changes in pH when you add your titrant, this is how the curve will look like. No? So, ito yung itsura ng titration curve. No? So, at the initial pH, ito yung pH ng acid. And then, when you add the titrant, the pH will slowly increase until biglang magkakaroon ng sharp change. Okay? So again, initial point, ito yon, wala kang dinadagdag na titrant. However, when you add titrant, onti-onti tataas yung pH. No? Mas nagiging basic yung solution. And once na biglang magkaroon ng sharp change, yun yung equivalence point. May sudden change sa pH, and we call that the equivalence point. Okay? So there will be a steep change in the slope of the curve. Okay? So ibig sabihin, na-reach mo yung equivalence point. Basta makakita kayo ng ganitong curve, equivalence point yon, yung biglang taas. No? So equivalence point yon. Ibig sabihin, the analyte is completely reacted with the titrant. Okay? So yun ang equivalence point. Then, after nun, magpa-flat na ulit, magpa-plateau na siya. Post-equivalence na yan. Okay, so again, ito yung curve when you plot the pH against the volume of titrant added. So initially, mababa yung pH. However, when you add titrant, unti-unti aakyat yung pH until biglang maging pH equals 7. Equivalence point yon. Then after ng equivalence point, nagdagdag ka ng titrant, maging basic na yung pH. Okay, so ito yung itsura ng titration curve for strong acid, strong base titration. Again, remember the formulas we need to use. Initial, the concentration of H plus is equal to the concentration of your acid. At pre-equivalence point, the concentration of your H plus is equal to mole acid minus mole base divided by the volume total. Okay? Or MAVA minus MTVT divided by the volume total. At equivalence point, only water will contribute to the pH. So that means the concentration of H plus is equal to the square root of Kw, or basically pH is equal to 7 automatically at equivalence point. And then after equivalence point, sobra ka na ng base, no? So to solve for the amount of OH, that is mole base minus the mole acid divided by the volume total. Okay? So these are the 4 equations that we need to use, no, in order to solve for the pH at different stages. Ang daming equation, no? Yes, pero itabi nyo lang to. I-screenshot nyo na to kasi ulit-ulit lang talaga yung gagamitin nating equations. Okay? So basta alam mo kung nasang stage ka na, basta alam mo kung nasang stage ka, initial, pre-equivalence, or post. Basta alam mo kung asang stage ka, you know the equation that needs to be used. No? Okay. So, try tayo. Okay. So, try natin, do the calculations needed to generate the hypothetical titration curve for the titration of 50 ml of 0.05 molar HCl with 0.1 molar sodium hydroxide. Okay. So, our analyte here is the HCl. So, this is our analyte. Ito yung analyte. And ito yung titrant. 0.1 molar sodium hydroxide. Okay. So, ito yung MA. Ito yung VA. Okay. And this is the molarity of titrant, MT. On this table, makikita natin volume titrant added. 0 ml, 10 ml, 25 ml, 25.1 ml. Ano gagawin ko dito? Ayun yung first tanong natin. Ano meron dyan? Okay. So, kailangan Sa titration, pag nagsosolve tayo ng pH, you should know kung anong volume ang equivalence point, no? Anong volume yung equivalence point? Okay. So, yun yung una mong gagawin kapag nakakita ka ng ganitong titration problem. Identify first the equivalence point volume. Paano ko gagawin yun, sir? Paano? Ano yung sabi ko kanina? Balikan natin yung slide na yun. Ang sabi ko kanina, at equivalence point, mole titrant equals mole analyte, di ba? Or MTVT equals MAVA. Okay? So, gagawin mo muna, when you encounter this problem, identify first the equivalence point volume. Hanapin mo saan yung volume magkakaroon ng equivalence point. Okay? So, paano yon? I will use the formula MAVA equals MTVT. Okay? Aalamin ko muna yung equivalence volume. Okay? So, ano yung molarity ng analyte? 0.05 molar times volume ng analyte, 50 ml. Equals, ano yung molarity ng titrant natin? 0.1 molar times what volume at equivalence point. Okay, so ito yung missing natin. Volume of titrant at equivalence point. So doing algebra, the volume of titrants at equivalence point is calculated as 0.05 times 50 divided by 0.1. Okay. So calculate natin yan. 0.05 times 50 divided by 0.1. So that's equal to 25 ml. Okay. So from this calculation, we know that this volume is the equivalence point volume. Okay? So ganun gagawin nyo. First thing first is alamin nyo kung ano yung equivalence point. Okay? So once alam mo na yung equivalence point, you can assign the different stages for different volumes na. O ito, zero volume titrant. Ibig sabihin, ito ay initial. Ito, 10 ml. Ibig sabihin, hindi mo pa na-achieve yung equivalence point. So, ibig sabihin, ito yung pre-equivalence point. Then, at 25 ml, equivalence point na yon. And at 25.1, lagpas na siya sa equivalence point. We call this the post-equivalence point. Okay? So, yun yung una mong gagawin. Ano yung una mong gagawin? Alamin mo kung ano yung volume ng titrant at equivalence point. What equation ang gagamitin? Ito. This equation will give us an idea ano yung volume ng titrant at equivalence point. Plug in mo lang ito, pati ayon. You will get the volume of titrant at equivalence point equal to 25. Once alam mo na to, mag-assign ka na kung anong stage yung ibang volume. Pag 0, edi syempre initial yan. Pag 10 ml o less than 25 yan, so ibig sabihin, pre-equivalence point yan. Then ito, 25.1, lagpas na siya sa 25. Ibig sabihin, post-equivalence point na yan. Okay? So yun yung first step na gagawin nyo. Alamin kung ano yung volume at equivalence point using this formula. After nyo malaman yung volume at equivalence point, you will assign the stages. Mag-assign na kayo ng stage. 4 lang naman yan. Initial, pre, EP, post, di ba? Okay? So, ganun. Sir, given po ba lagi yung mga volume na yan? Yes po. Ibibigay ko yung volumes. Bibigay ko yung volumes. Don't worry. Bibigay ko yan. Kunwari, sasabihin ko, 22 ml. Ayan. Pre-equivalence point yan. Given yun. So, baling gagawin niya lang talaga sa titration is given na naman ito, given na ito, given na ito. Alamin mo na lang kung anong stage yan. Tapos anong equation yung gagamitin mo. Okay? So, yun lang yung goal nyo. Pag alam nyo na yung equivalence point volume, assign mo na yung stages, then once alam mo na yung stages, you know the corresponding equation na. Kasi sinulat ko na siya dito sa table. Okay. Susundan mo na lang. At initial stage, ito yung equation ko. At pre-equivalence, ito gagamitin ko. At equivalence, ito. At post, ito. Okay? So, ganun. Don't worry, assigned yung volume. Bibigay ko na yan. Okay? Ang gagawin nyo na lang is solve yung pH. Sabihin nyo kapag may hindi clear. Kasi, to be honest with you, nung undergrad ko, nahirapan ako dito. BS Chem ako, tapos nahirapan ako dyan. What more kayo, di ba? Kasi baka mamaya, mas lalong, ano daw? Ano sabi ni sir? Tanungin niyo ako pag may question kayo, Kasi mahirap talaga tong topic na to. Pero, tutulungan ko kayo para clear yung question sa isip, Okay. So, ganun Pag may question, itanong. Kasi medyo technical tong topic natin na to. Ang daming equation eh. Okay. So, para hindi kayo mawala talaga, sabihin nyo kung may problem. Okay. So, yan. Kasi ang problem with titration, kapag hindi mo alam kung ano gagawin mo, pag tinitigan mo lang siya, wala kang masasagot. As in, 4 points yan. Isang point dito, isang point dito, isang point dito, isang point doon. Wala kang masasagot. So, ang gagawin nyo is, ito na nga, no? Ang gagawin nyo is, itanong nyo. Kapag, sir, ano uli? Hindi lang ako nasundan, So, don't hesitate to ask kasi mahirap talaga tong topic na to. Pero kaya. Kaya yan. Okay. Nakagraduate nga ako. That kayo din, di ba? Okay. Tsaka by the way, share ko lang, no? Ang chemistry ay kasama na sa qualifying exam nyo. Bago kayo mag-third year, magta-take kayo ng qualifying exam. Kasama na yung chemistry doon. And syempre, pag sinabing chemistry, kasama tong topic na to. So, kailangan nyo talaga mag-aral maigi. Tsaka buti na lang, may YouTube channel tayo. Pwede nyo panoorin ulit bago kayo mag-qualifying exam next year. Okay? So, yun. Good luck. Anyway, so yan. So, ano yung ginawa natin? So, ang progress natin is that we were able to identify the volume of titrant at equivalence point. Okay? So, pag alam mo na yung volume ng titrant at equivalence point, you can now assign stages, no, to different volumes. Pag 0, automatic initial yon. Pag ang volume ay less than this, pre-equivalence yon. But if the volume is greater than this, post-equivalence point. So, yan. So, may 4 na stages na tayo. And ano susunod? Alam mo na yung 4 na stages. You now know how to solve for their pH. No? So, at equivalence, at initial muna. Okay. So, at initial, what is the formula to be used? No? Para malaman yung pH. Sabi sa PowerPoint kanina, to solve for the pH, that is just the concentration of your acid. Okay? So, ano ba yung concentration ng acid? 0.05 molar. Okay? So, kunin mo yung pH. Ano yung pH? Negative log ng 0.05. Okay? So, this negative log 0.05. Ang pH ng solution ay 1.30. Okay? So, ganun lang. Yun na yun. So, i-graph natin. No? Kunwari ito, 1, 2, graph natin. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Itong 1.30 somewhere here. Okay? So, 0 ml to. Volume ng titrant. So, ayun yung point ng ito yung initial pH, 1.3. Somewhere there. Okay? Ipapa-require ko ba kayo mag-graph? Hindi. Bakit ako nag-graph dito? Wala lang. Para makita nyo yung curve. No? Para masanay kayo sa curve. Pero hindi nyo gagawin to, ha? Okay, mag-worry masyado. Gusto ko lang ipakita yung curve. Okay, so again, the initial pH can be calculated from the concentration of the acid. Negative log mo lang yun. Yun na yun. Okay? Okay, so let me summarize this slide. Initial pH equals negative log concentration ng acid. Okay, or negative log 0.05. Kuha natin 1.30. Yun na yun. Di ba? May sagot ka na, may 1 point ka na. Next one, pre-equivalence point. Anong equation gagamitin dito? The equation that is needed is ito. Concentration H plus equal mole acid minus mole base added divided by the total volume. Ito yung equation na gagamitin. Mole acid minus mole base divided by the total volume. Bakit ito yung equation? Kasi sabi ko kanina, at pre-equivalence point, nababawasan yung acid natin. By how much? This much. Itong equation na ito yung gagamitin mo to determine how much nabawasan yung acid. Mole acid minus mole base. Okay, so let's express that into molarity analyte, volume analyte minus molarity titrant, volume titrant. Okay? So ito yung mole ng acid, MAVA. Ito yung mole ng base, MTVT. Kasi ano ba yung titrant? Base, di ba? So yan. Ano ba yung analyte? Acid. Okay, so yan yung formula. Divided by the total volume. What's the molarity of analyte? Ito, 0.05. 0.05 times the volume of analyte. 50 ml pa rin. Hindi yan magbabago. 50 ml talaga yan. Sabi dito eh. Ano yung nagbabago? Yung volume ng titrant. Okay? So, hindi yung volume ng analyte. Minus, molarity ng titrant, 0.1 times, anong volume na to? 10 ml. Okay, so 10 ml. Divided by the total volume. Ano na yung total volume mo sa Erlenmeyer flask? You have 50 ml from your analyte plus 10 ml from your titrant. So, 50 plus 10. May tanong? Again, ano to, sir? Okay, ganito. Sabi ko, at pre-equivalence point, the concentration of acid can be calculated as mole acid minus mole base divided by the total volume. Paano mo kukunin yung mole acid? MAVA. Paano mo kukunin yung mole ng base? MTVT divided by the total volume. Okay? So, ano yung MA? Sabi doon, 0.05. Ayun. Ano yung VA? Volume analyte. Yun, 50 ml. Plug in mo doon. Minus molarity ng titrant. Ano ba molarity ng titrant? Ayun, 0.1. Plug in mo doon. Ano yung volume ng titrant? Ito, sabi dito, 10 ml. Plug in mo doon. Ayun. So, na-plug in mo na lahat sa numerator. Yung denominator, paano to? Pag sinabing volume total, that's the volume of analyte plus the volume of titrant. Ipag-add mo lang yan. Okay? So, yan. 50 plus 10, yun na yung total volume. 60 ml na yun. Okay? Okay, so yan. Given that equation, we can now solve for the concentration of H plus. 0.05 times 50 minus 0.1 times 10 divided by 50 plus 10. So, the concentration of H plus is 0.025 molar. Okay? So, pH is negative log of 0.025. Okay? Which is 1.60. Okay? Ayun, tumaas yung pH from 1.3 naging 1.60. Bakit tumaas yung pH? Kasi nagdagdag tayo ng titrant. Okay? Nagdagdag tayo ng base, kaya tumaas siya. Okay? So, kung i-graph ko yan, to 0 ml. Okay, so kung ayan yung ito yung ating initial, 1.3. At 10 ml yan ay 1.60 na. So, somewhere here. Okay, so ayan. Ayan na siya. Okay, so again, As long as you know the stage, there is a corresponding equation to be used. And plug in mo na lang yung given. Okay. So, yan yung sagot natin for this stage pa lang. Diba? Ang daming nangyayari, no? Okay. So, ganun talaga. Wala tayong choice. Okay. So, let me just show how dito. Pakita ko kung ano yung equation na ginamit natin. That's 50 times 0.05 minus 0.1 times 10. Papansin nyo yung ml, di ko na pinapalitan, no? Di ba dapat liters? Pero okay lang. As long as ml gamit mo sa lahat, you're good to go. Kasi di ba m times ml, molarity times ml is millimoles. Pag dinivide mo uli yun sa ml, molarity ulit. Di ba? Okay. So, gamitin na natin na ml yung volumes parate para masanay. So, this is the equation we use to determine the concentration of H+. Getting its negative log will give us 1.6. Yan yung pH ng solution at 10 ml titrant. Ito, at equivalence point. Ano yung equivalence point pH? Matic, 7 yun. Okay? Huwag ka na mag-isip dyan. 7 agad yun. Pag strong acid, strong base, ang equivalence point pH ay 7. Bakit? Bakit? Kasi, sabi ko, at equivalence point, only water is present. So, ibig sabihin nun, yung water lang yung reason bakit may pH. And bakit nga ba may pH? Because of water, self-ionization. The self-ionization of water is given as H plus equals square root of Kw. Okay? So, square root of Kw is 1 times 10 raised to negative 7. Pag ni-negative log mo yon 7. Diba? Okay, so yan. Pag ini-negative log mo yan, 1 times 10 raised to negative 7, di automatic 7 yung pH mo. Okay, so at 25 ml, andito na yung ating dito na yung ating curve. Okay, so yun na siya. And yun, malapit na tayo matapos. At post-equivalence point, lagpas tayo ng 0.1 ml. So magbabago yung equation na gagamitin natin. So what is the equation that needs to be used? Sir, constant po ba yung EP? Na 7 po siya. For strong acid, strong base, yes, 7 yan. Pero kapag weak acid, weak base, ibang usapan yon. Diba? Ang daming ganap, no? So kapag strong acid, strong base titration, 7 talaga yon. Okay, kahit anong mangyari, 7 yon. Pero kapag may weak acid, weak base, ibang ganap yon. Okay? So mamaya na natin problemahin yan. Basta again, kapag strong acid, strong base, equivalence point pH is 7. Fix yun. Okay? 7 talaga yun. Wala na tayong magagawa dyan. Ayun ha. Again, strong acid, strong base lang siya. 7. Post-equivalence point, ano sabi natin dito? There is an excess base, no? Okay, there is an excess base concentration. And to solve for the excess base concentration, the formula we need to use is OH equals mole base minus mole acid divided by the total volume. Basically, yun yung equation ng pre-equivalence point pero binaliktad mo. Okay? Babaliktarin mo lang to get the mole, to get the concentration of excess base. Okay? Again, pag excess base na, flip mo lang yung equation ng pre-equivalence point. So instead na H yung makukuha mo, OH makukuha mo. Okay? So pagbaliktarin mo lang yung acid base dito, gagawin mo siyang base minus acid. Okay? Pero wag nyo na kabisaduhin. Pero mas maganda kung alam nyo. Pero kung hindi nyo ayaw nyo kabisaduhin, eto na yung table. Okay? Susundin nyo lang yung table. Basta alam nyo kung anong stage na kayo. Okay? So yan. Okay, so tuloy tayo. Mole base. What's mole base? Molarity titrant, volume titrant. Okay? MTVT. Pag sinabi ko mole-based, MTVT. Okay. Sa ganitong case, okay. Okay. So, yan. MTVT. Molarity titrant 0.1 times 25.1 ml. Moles ng acid, MAVA. So, MA is 0.05 times 50. Okay? Hindi nagbabago yung molarity ng analyte. Okay? 50 talaga yan. Wala na tayong magagawa doon. Okay? So, yan. 0.1 times 25.1 mole ng base to minus 0.05 times 50. Ito yung mole ng acid. So, pinag-subtract mo yan, makukuha mo yung sobrang OH. Divided by the total volume. Ano na yung total volume natin? We have 50 na analyte plus 25.1 na titrant. Okay? So, yan. So, 50 plus 25.1. Ipag-add mo lang yung volume ng titrant and yung analyte. Okay? So, solve mo yan, makukuha mo yung OH. Solve natin. 0.1 times 25.1 minus 0.05 times 50 divided by 50 plus 25.1. Ang concentration ng OH ay 1.33 times 10 raised to negative 4. Negative log mo yan. Ano makukuha mo? POH, no? Ang makukuha mo, POH equals 3.88. Okay, so 3.88 yung POH. Ang gusto ko, pH. Di 14 minus POH. So the answer is 10.12. Dapat matik na yun ha. Pag gusto ko pH, alam nyo na yung gagawin nyo. Yung OH, convert to POH, then minus 14. 14 minus this, pH na yun. So kailan alam nyo na yung pasikot-sikot ha. Okay, so if i-graph ko yan, 25.1, that's 10, somewhere here. Okay, so let me draw the curve, no? So mapansin nyo, the curve is ganito. Parang pag ganun yung curve niya, di ba? So slowly mag-i-increase, then sudden, and then maakit siya bigla, no? Tawag namin dito is inflection point. Okay, so inflection point is the sudden change in the slope of a curve, no? Sa mathematics may ganyan din, inflection point. Pag favorite nyo yung math, familiar kayo din sa inflection point. Okay? So yan, mapapansin nyo, slowly increasing, then suddenly biglang magiging 7 at equivalence point, and then magpa-plateau yan sa taas. Okay. So the region wherein there is a sudden change in the slope, we call that the inflection point. Okay. So sa inflection point nangyayari yung equivalence point. Okay. Di ba? Ang daming point. Okay. Doon nangyayari yung equivalence point. Doon nangyayari yung end point din. Okay. So sa region na to, andun nangyayari yung end point. Okay. So to summarize, hindi pa tayo tapos sa mga kailangan natin gawin, pero okay lang. So to summarize, anong ginawa ko nung una? First thing na gagawin mo is alamin ang equivalence point volume. Paano? Mole titrant equals mole analyte, di ba? Yun yung ginamit ko. This times this equals this times x, no? Question mark. Ano yung x? Solve for x. Nakuha natin is 25. Okay. So since alam ko yung 25 yung equivalence point, then I can now assign stages to other volumes. Ito, initial siya. Ito, pre-equivalence kasi less than this. Ito, lagpas sa 25. So ito, post-equivalence. And then, once you assign the stages, there is a corresponding equation. Okay, may corresponding equation kada stage. All you have to do is just to plug in all the given numbers. No? Plug in mo lang. 50 ml. Ano yon? VA. 0.05 MA yon. 0.1 empty yon. O yung VT dito mo kukunin. Plug in mo lang. Then you will get the pH. Okay? So, ito yung sagot. Ito yung nasa PowerPoint nyo. So, this is the summary. Cleaner version. So, yan. So, hopefully, clear, no? Kasi pag hindi, GG tayo. Sir, palagi po ba 2 decimal places? Commonly, yes. Common na ginagamit 2 decimal places. Minsan 1 decimal place, minsan 2 decimal place. Pero mostly 2 decimal places talaga. Sa ano naman, sa quiz nyo, ano naman yun multiple choice eh. Kaya alam nyo na, round off, round off. Okay. Ayan, so practice tayo. Okay, ang gagawin ko dito, aalamin ko lang yung endpoint. Then I will assign the stages. Then, toka-toka tayo. Ano yung pH niya? Okay. So, ganun gagawin natin dito. So, this is parang worksheet na rin natin to. Although, gagawa pa ako ng additional worksheet para mas marami kayong reviewer. Okay. So, ayan, given the info, we have 10 ml of 0.1 HCl that is titrated with 0.05 molar sodium hydroxide. The volume are given. Okay. So, ano gagawin mo kapag nakakita ka ng ganyan? Huwag ka iiyak. No? Ang gagawin mo, hanapin mo yung volume of titrant at equivalence point. What is the equation to be used? When you are looking for the volume titrant at equivalence point, you use the equation mole analyte. Ay, ba't naging blue to? Red. Mole analyte equals mole titrant. Ito yung equation na gagamitin mo parate. Ano yung purpose na itong equation na to? To identify the equivalence point volume. So, MA VA equals MT VT. 1-to-1 yung ratio niyan. Okay? Kasi monoprotic tayo eh. So, isang acid, isang base. So, MAVA equals MTVT lang yan. Okay. So, what's next? MA. Ano yung MA? Yung unang sinasabi parate, yun yung analyte. Okay. So, basta kapag analyte, sinasabi yung volume, sinasabi yung molarity agad. Yung volume ng titrant, paiba-iba yun. Okay. So, ito. Pag nakita nyo paiba-iba yung volume, titrant yun. Pag fix yung volume, analyte yun. Okay? And always, first na sinasabi yung analyte, bago yung titrant. Okay? May keywords ka naman eh. Kunwari, is titrated with. Ibig sabihin, ito yung titrant. Okay? So, be careful with the sentence. Unang binabanggit ay yung analyte, followed by the titrant. Okay, so ito yung info natin about MAVA. So that's 10 times 0.1. MTVT, ang alam ko ay 0.05 ang molarity ng titrant times, I don't know. Solve for X, no? Solve for the VT at equivalence point. Solve for X lang yan. So that's 10 times 0.1 divided by 0.05. 20 ml. So, the equivalence point volume is 20 ml. Okay. So, ito yung volumes ko, di ba? Ayun, 20 ml. I will assign this as the equivalence point. Okay. Yun yung first nyong gagawin, ha? Okay. So, yan yung una nyong gagawin. Alamin ang equivalence point volume. Ito yun. Then, since alam mo na yan, mag-assign ka na ng stages. O, pag 0, edi automatic, initial yan. O 1, o less than yun sa 20, edi pre-equivalence. Ito, pre-equivalence point. Ito, pre-equivalence point. O, lagpas na to sa 20, 20.1. O, ito, post-equivalence point na yan. O, post-equivalence point. And another post-equivalence point. Okay? So, yun yung approach natin sa titration. By the way, no, if you watch YouTube videos, no, yung ibang YouTube videos, kunwari kay Organic Chemistry Tutor, kay Khan Academy, iba yung approach nila sa titration, especially kapag weak acid, weak base, no. So, ang approach ko, yung simplified, no, yung approach nila yung equilibrium. Kaso, ang goal ko is, ano, i-simplify natin yung equilibrium. Kaya, mapapansin nyo may difference sa approach ng turo sa kay Khan Academy, kay ah, Organic Chemistry Tutor, no? Kay Chemistry Jesus natin, si Professor Dave, no? So, iba-iba yung approach nila. Ibang-iba yung approach nila compared sa akin. Kasi yung akin, simplified yung gagawin ko. Sa kanila, ini-equilibrium pa nila minsan. Okay? So, yan. Mas okay na sundan nyo na lang yung equations na binigay ko. Kaya nga, pinopost ko na yung equations. Yan. Ginaganyan na natin. Although, mas accurate yung makukuha mo with equilibrium. Pero, again, so, sayang yung time. No? Baka tapos na yung exam, hindi ka pa rin tapos mag-equilibrium. Natagalan ka sa nakatagalan ka sa quadratic equation, di ba? Ayun yung ayaw ko eh. Kaya summarize parati yung ating equation. Anyway, so yan, nakapag-assign na ako ng stages, initial, pre-equivalence, post. O, anong sagot sa equivalence point? Matic 7. Kasi strong acid, strong base yan. Matic 7 yan ha. Ayan. Pag kayo nagkamali pa dito, ewan ko na lang. No? Ayan, hindi pwedeng maging 0 yung score niya kasi may 7 na agad. No? Pag strong acid, strong base. Yan. Okay. Initial. Paano mo kukunin yung pH niyan? Di yung concentration ng acid mo, yun lang yun. Okay. So we say H plus is equal to the concentration of acid. In negative log mo yun, you will get the pH. So negative log ng 0.1 is 1. pH is equal to 1. I-graph uli natin. Wala lang. Hindi naman required mag-graph, pero gusto ko lang. Para makita nyo yung curve, di ba? Sayang nga, hindi tayo naglalab ngayon eh. Kasi kung sa laboratory to, gumagawa na kayo ng curve sa Excel. Nakaka-amaze kaya to. Nakikita mo yung curve gumaganon sa Excel. Wala lang. Tapos pwede mo siya gamitan ng calculus. Okay. So, yan. So, at volume of titrant equals 0, the pH is 1. O, yung 20, lagay na rin natin dito sa graph 7. Yung natira, solve natin. Okay, so at pre-equivalence point, remember, at pre-equivalence point, the equation to be used is MAVA minus MTVT over volume total. Okay, so all you have to do is to plug in the info, MAVA, MTVT, divided by volume total. Plug in mo yung mga info na to, and we will get the pH. So ako, unahan ko na kayo ha, para matapos na tayo sa slide na to. Although, pwede nyo ito sagutan uli after the session. Okay. So at 1 ml, aalamin ko yung pH. Pa-plug in ko na ha. Kayo, plug in na rin kayo dyan. Okay. So at 1 ml, the pH is 1.06. Bilis, di ba? Kasi once na ma-type mo na siya sa calcu, papalitan mo na lang yung volume ng titrant. Okay. So yung 1 gagawin kong 10. Okay. So ganun lang. So at 10 ml titrant, the pH is 1.60. Papalitan ko ulit yung volume ng titrant, 19.9. That's 3.78. Nakuha ba yan? Hintayin ko kayo. Ipo-point ko lang siya dito sa graph. 1 ml is 106. Ito yan. 10 ml, 1.6. 19.93. Okay po, nakuha nyo na yung sagot na. Basta plug-in lang. Palitan nyo na lang yung MT pati volume total. Yung V pa pala, pati volume total. You will get these values. No? Okay. So those are the pH at initial, pre-equivalence, and at equivalence point. How about post-equivalence? Palitan ko na to. At post-equivalence point, for strong acid, strong base titration, the equation to be used to solve for the excess OH is this. Mole base minus mole acid divided by volume total. Or in terms of analyte and titrant, that's MTBT minus MABA. So yan. Ano gagawin nyo? Plug in ulit. Plug in lang. So unahan ko na kayo para masagutan ko na yan. Okay, so this is 10.22. Huwag kayo magpanic pag naunahan ko na kayo. Siyempre, ano na, alam ko na paano sagutan to. Pero kayo, so, hintayin nyo na lang kung tama yung sagot nyo. So, 25 ml, that's 11.85. And at 30 ml, 12.09. 12.10. Please check if you arrive with the same result. Okay lang kahit malapit. No? Nag-round off ako eh. Okay. So, i-graph ko siya. So, at 20.1, that's 10.22. At 25, 11.8. Somewhere there. At 30, 12. Okay. So, kung mapapansin nyo, kung i-graph ko yan, this is the curve. Diba? Ang cute, diba? Ayan. Ito na yung nasa, diba? Nasa harap kanina. Nasa earlier slide. Ganun na ganun yung curve. Diba? Astig. Ewan ko kung na-appreciate nyo, pero syempre, chem kasi kami, kaya pag nakakita kami ng ganyang curve, ay, ang galing, ganun kami. Ay, pero ayan na. So, it means na yung pinagsasabi ko kanina, hindi yung joke time. Ayan, no? Sakto nga yung graph dun sa graph kanina. Okay. So, yan. So, I hope you arrive with the same answer. No? If you have any question, you can raise them. Okay, please raise them. Ako na yung nagre-request na i-raise yung concerns para masundan. Kasi the problem with this topic is kapag na-delay ka, delayed ka na talaga until the end. Okay, so let's, wag natin hayaan mangyari yun. Okay, kailangan tuloy-tuloy lang. Okay, so again, yan yung sagot natin. You can take a screenshot or pag na-upload na to sa YouTube, dun yun na lang i-screenshot. Okay, so again, the summary is that for strong acid, strong base titration is that you will start with a very low pH given that strong acid lang yung given muna. And then once you added your titrant, strong base, slowly mag-increase yung pH until an inflection point will appear. So this is the inflection point. And at the inflection point, you will find the equivalence point. In our case, that's 25 ml. Okay. Pag nagta-titration kayo dito, colorless to. Then once na dumating na tayo sa inflection point, dun na magiging pink yan. Bigla-bigla magiging pink yan. Then kapag lumagpas ka na, purple na yan. Okay. Panoorin nyo yung video na share ko kanina kasi walang audio. Panoorin nyo yun. Okay. So makikita nyo at this point, magiging faint pink. Then pag lumagpas doon, dark pink na siya. Okay. So ganun. And also, depending on the stage of your titration, there's a corresponding equation that can be used to determine the pH of the solution. Okay. Be mindful that for initial concentration, that is just the concentration of your acid. In negative log mo lang yun. At pre-equivalence point, the acid slowly decreases because of the presence of the base. Slowly nanoneutralize siya. So the equation to be used is mole acid minus mole base divided by volume total. At equivalence point, pag strong acid, strong base, 7 yun. Why? Because only water will give the pH value. Okay? Tubig na lang kasi yung present doon and the salt. Yung tubig, yun yung magbibigay ng pH value. Okay? So that's why it is 7. Okay? And then at post-equivalence, there is an excess base. So to solve for the excess base, that's the mole base minus mole acid divided by the total volume. So from OH, gawin mong POH, then eventually to pH. You will get these values. Okay? So I hope na clear tayo. Pag may question, don't hesitate to raise your hand or to message here, ha? Alam ko medyo ang daming ganap tong topic na to. Pero wala tayong magagawa. Required to sa analytical chemistry. So, yan. So, if we grab that, we will get this this cute curve. No? Diba? Ang ganda ng curve. So, yan. Okay. So, we are done with the first type. Second type tayo. This time, baliktad naman. Diba kanina, strong acid, strong base. Ngayon, strong base, strong acid. What does it mean? Di ba yung nauna, sabi ko, analyte yon. Yung sumunod, yun yung titrant. Okay? So in our case this time, strong base, strong acid is a titration wherein yung strong base ay yung analyte, yung strong acid ay titrant. Basically, baliktad. Baliktad yung mga, baliktad yung nangyari kaysa sa kanina. But the equation is similar. Okay? So yan. Again, pag strong base, strong acid, baliktad yung nangyari. Baliktad lang. Okay, so you start with a high pH, then after the titration, you will end with a low pH. No. Okay, so we still have the 4 stages: initial, pre-equivalence, equivalence, and the post. And these are the species present in our stages. So initial stage, we have the metal hydroxide. Okay, pwedeng sodium hydroxide yan, potassium hydroxide, no? Kaya MOH lang nilagay ko. Pwedeng lithium hydroxide, no? So this is our strong base. Okay, and water. And sino sa dalawa yung magko-contribute sa pH? Di yung metal hydroxide, no? Yung strong base natin. So, to solve for the pH, kung ano yung kanyang concentration, makuha mo yung POH nun. And then 14 minus that is the pH. Okay? Medyo maingay sa kapitbahay. Anyway, so basta ganun lang. Again, ano uli nangyari? So at initial stage, may base cam present. So that means the base is contributing to the pH of the solution. So to solve for the pH of the solution, given yung base mo, kunin mo yung concentration ng base, equivalent yun sa OH concentration. I-negative log mo yon, makukuha mo yung POH. To solve for pH, that is 14 minus POH. Okay? Alam niyo na yan. Ginagawa na natin yan. Chapter 1 pa lang. Okay? So from pH, gagawing POH, vice versa. Okay? So initial stage, wala dapat tayo problema dito. Kung ano yung concentration ng base, yun na yun. Negative log lang. Tapos 14 minus that pH. At pre-equivalence point, no, ito naman yung nangyayari. Yung base natin nababawasan. Okay? yung base natin nababawasan. So, the equation to be used is this one. This is a modified version doon sa strong acid, di ba? Strong acid, strong base. Okay. Instead of solving for H plus, we will solve for the OH minus. No? Okay. So, this is the mole base. Ay, teka lang. This is the mole base minus mole acid divided by V total. Okay. So, to solve for the concentration of OH, as you add your titrant, is this mole base minus mole acid divided by V total. Remember that your base is the analyte, so MAVA yon, MAVA. And yung titrant mo ay yung acid, so MTVT. Pag susubtract mo lang sila, divided by the total volume, you will get the concentration of your OH. And to get the pH, convert mo to sa POH, then 14 minus POH is pH. So ano, 'di ba? Mapapansin niyo may resemblance to sa kanina ha. Yes, meron siyang resemblance. Baliktad lang 'yung nangyari. Okay? At equivalence point, all the base will be neutralized to form the salt and water. Only water will will cause for a pH reading. No? Ito lang 'yung magbibigay ng pH reading because it auto-ionizes. And the auto-ionization of water tells us that the pH is 7, 'di ba? Sa equilibrium 'yon, 'di ba? So automatic 7 pa rin yung equivalence point dito. Strong base, strong acid. Post-equivalence point tayo. So once you add more acid titrant, again, acid na yung titrant natin. So once you add strong acid na titrant, excess na yung acid, no? And to solve for the excess acid, that is the mole acid minus mole base divided by the volume total. Okay. Or in equation, that's MTVT minus MAVA divided by V total. It's the moles of your acid minus the mole of the base divided by the volume total. To get the pH, negative log lang yan. Okay? So again, strong acid, strong base is similar with strong base, strong acid. Nagkabaliktad lang yung case, no? Kung kanina yung analyte natin ay yung acid, ngayon ang analyte natin ay yung base. Kung kanina ang titrant ay base, ngayon ang titrant ay acid. So basically, it calls for the change, no? Pag switch mo lang yung acid pati yung base sa equations natin. Okay? So kaya nga sabi ko sa inyo earlier, as long as you know the condition, alam nyo kung ano gagawin nyo. Okay. Alamin mo kung ano yan, SASB or SBSA. Magkaiba kasi equations doon. Okay? Baka mapagbaliktad nyo yung analyte titrant eh. So, kailangan alamin nyo muna kung ano yung mga analyte and titrants natin. Okay? So, yan. Be careful. Don't worry, di naman kayo malilito eh. Ang unang sinasabi parati ay yung analyte. So, pag nakita nyo SBSA, SB, yun yung analyte. SA, yun yung titrant. Okay? So, ganun lang. Be careful. And ito yung equations natin. Similar, reversed nga lang. Okay? If you graph the pH changes when you add the acid titrant, this is how it will look like. So, initial pH is very high given that base yun eh. So, mataas yung pH nun. Then, slowly when you add titrant, it will slowly decrease until you reach the inflection point. Again, the inflection point is the steep slope. Okay? Itong sudden change sa slope, inflection point tawag yan. Spell ko ulit. Inflection point. And once you have the inflection point, you have your equivalence point. Andun yun sa inflection point, yung equivalence point. Then, after nun, pag nagdagdag ka pa ng titrant na acid, SA to sorry. Pag nag-add ka pa ng titrant na acid, ayun, magiging mababa na yung pH because there is an excess acid. Okay? So again, for SASB, kabaliktaran lang yun ng SBSA. Okay? So, nagbaliktad lang yung curve natin. And as a result, yung equation nagbaliktad din. Ha? Yan. Let's try this. Onti na lang kasi alam na natin gagawin natin. So, calculate the pH during the titration of 50 ml of 0.05 molar sodium hydroxide with 0.1 molar HCl at 25 degrees Celsius after the addition of the following volumes of reagents. 24.5, 25, 25.5. Okay? Ano gagawin mo? Di kung ano yung ginagawa natin, ganun pa rin. Alamin mo yung equivalence volume. Equivalence point volume. Okay? Again, yun yung una mong gagawin. Alamin ang equivalence point volume. Okay? Wag na... Okay? So, yun lang muna gagawin nyo. Also, sabi ko rin kanina, kung ano yung binanggit na una, yun yung analyte. And yun na huli, yun yung titrant. So, wag na kayo malito, ha? Yung unang sasabihin, yun yung analyte. Ay, lumabas na yung sagot. Ito yung titrant. Okay? So, yan. Alamin yung equivalence point volume. Again, ano yung condition natin to find the equivalence point volume? We say that analyte, mole of analyte, teka lang. We say that mole of analyte is equal to the mole of titrant at equivalence point. Okay. How do we solve for the moles analyte? That's MAVA. How do we solve for the moles of titrant? That's MTVT. Ang gusto natin, hanapin yung volume ng titrant at equivalence point. So that is MAVA divided by MT. Okay, plug in. Molarity analyte 0.05 times 50 ml divided by molarity titrant 0.1 molar acid. Plug in 0.05 times 50 divided by 0.1, 25. Okay, so we can say that this 25 ml is the equivalence point. No. Yun yung una nyong gagawin. Okay? So, ano una nyong gagawin? Alamin ang volume of titrant at equivalence point. Because from that, you can assign the different stages na initial, pre-equivalence, equivalence, and post-equivalence. Ito, less than 25. Edi ano to? Pre. Ito, lagpas 25. Edi ito ay post. Diba? So, yun yung una mong gagawin na. Bakit ko inuulit-ulit to? Kasi very vital to. Okay? Again, solve first for the volume of titrant at equivalence point using this equation. Okay? So, yan. Once alam mo na, remember that for every stages, there is a corresponding equation. For SBSA, ang pre-equivalence equation ay OH minus equals molarity analyte, volume analyte minus molarity titrant, volume titrant divided by V total. Okay? So, kabaliktaran to ng sa SASB. SBSA tayo ha. Okay. Okay, mali to. SBSA. Iba yan sa SASB. Okay. So, kapag SB na una, OH masosolve mo muna. Okay. So, yan. This is the equation to be used. So, kindly refer to this table na lang. Yan. So, kindly refer to this table para makita nyo yung equations. Okay. So, yan. Let's plug in the given. So, molarity analyte. So, that's 50 times 0.05 minus molarity ng titrant 0.1 times 24.5 divided by total volume 50 plus 24.5. So that will give us the concentration of OH. Plug in na lang. 50 times 0.05 minus 0.1 times 24.5. 50 plus 24.5. The concentration of OH is 6.71 times 10 raised to negative 4. POH is negative log of that, 3.17. And pH is 14 minus 3.17, 10.83. Okay. Ganun lang. Ganun pa rin. No? Kung ano yung process kanina, ganun din, except that nagkabaliktad lang yung ating case. No? So, yan. As long as you know the equation to be used, madali na kunin yung pH. No? So, ganun. So, we start with 10.83. Okay. Sobrahin ko na to ha. Nasa next slide naman yung yung solution. So at equivalence point, now what is the pH for strong base, strong acid? Matic 7. Bakit? Because for strong acid, strong base titration at equivalence point, only water is present, no? And the salt. Ang nagko-contribute sa pH ay yung water lang. So according to self-ionization of water, the pH of water is 7 because of this. No? H plus equals square root of Kw. Sa equilibrium to. Kaya 7 yan. Post-equivalence. How about this one? There is an excess acid. Okay. Sobra na tayo ng acid. Kasi acid yung titrant natin. Lamagpas na tayo sa equivalence. So there is an excess acid. To solve for the excess acid, that is the mole acid, MTVT, minus the mole base, MAVA, divided by the volume total. Okay. Plug in. Okay. So that will be 0.1 times 25.5 minus 50 times 0.05 divided by 25.5 plus 50. We will get the concentration of H plus. Okay, so the concentration of H plus is 6.62 times 10 raised to negative 4. If we get the negative logarithm, that will be 3.18. Okay. So kung i-curve mo yan, pag ganun yan. Hindi ko na inayos yung curve. Pero ganyan, we start with 10, then we will reach 7, and then 3. Okay? So that's the strong acid, strong base, and the strong base, strong acid titration. Again, don't confuse yourselves with the two. Kung sino na una, yun yung analyte. Kung sino nasa dulo, yun yung titrant. Okay? So in our case, SBSA, ibig sabihin nun, SB, ito yung ito yung analyte. SA, ito yung titrant. So ibig sabihin nun, the graph will look like this. Base kasi yung analyte mo. So you start with the high pH. Then when you add titrant, bababa yung pH. Okay? So again, this has the similar concept with the previous one. Okay? So ito yung sagot natin. Ito yung summary. And nasa naman to, nasa PDF, no? So yan. So for your na lang, for your home activity, no? Sagutan din naman natin ito sa next meeting, no? So this is the question. I want you to identify the stages, no? Solve for the pH, no? And then graph, no? Try natin mag-graph kayo. Try lang. Okay. Kasi alam ko may biostatistics kayo, 'di ba? May graph doon. So kailangan masanay tayo onte. Gawin niyo na lang increments of 2.5, 2.5, 5, 7.5, so on so forth. Basta magkasya yung increments dito. So pH 1 to 11 yung kasya dito. Okay, bahala. Graph nyo yan. Then, kailangan ang graph, since ito ay SBSA, pag ganito ang itsura. Okay? So, try nyo na lang yan at home. Although, I will give the answer next meeting. Okay? So, before we end our session today, sir, paano po pag nag-iba yung temperature? Di ba sabi natin last time, ganito, yung temperature ay related sa equilibrium constant, di ba? So at 25 degrees Celsius, Kw is 1 times 10 raised to negative 14. Pero kunwari, naging 30 degrees Celsius yan, magbabago yung Kw. Okay? So, pag ganun, kunwari, nagbago yung temperature, ang usual na magbabago ay yung volume endpoint. However, ito yung however ko doon. We don't care too much about the temp. No. Okay. Hindi natin siya masyado papansinin to make things simpler. Okay. So we always assume that all the experiment is conducted at 25 degrees Celsius. Bakit? Kasi at 25 degrees Celsius, pH of water is 7. Pero kunwari at ibang temperature, magbabago yung pH at neutral. Pwedeng 6.98, pwedeng 7.02. Pero again, to simplify things, no, yung temperature ay as is lang. Usually 25 yun sasabihin natin dyan. So, you don't have to worry. Pero, sabi ko nga sa inyo, kailangan alam nyo at different temperature, Kw changes. So, that means the pH of water changes as well at different temperature. But for simplicity, 7 lang muna at 25 degrees Celsius yung pH natin. Okay? So, yun na. So, ano lang, chill lang. Okay lang yan. So, 25 naman yan madalas. For example, to 25, to 25. Basta kailangan hindi nyo nakakalimutan ha, yung relationship ng temperature with the ion product of water. Okay. Pero, hindi na natin masyadong iisipin yun ngayon. So, I want you to draw the curve dito ha. Try nyo na lang. So, before I end my session today, okay, so hindi ko sasagaran yung oras kasi alam ko parang ano kayo, no? Parang siguro nasabaw na kayo agad. Ang dami kong sinabi. Okay, so to give you an insight of what we will discuss next meeting, okay, so ito yung ganap. Weak acid, strong base, and weak base, strong acid. Okay, so hopefully makapag-study na kayo in advance, pero kung napanood nyo na yung sinend kong link sa inyo last week, no, may idea na kayo dito. Okay, so daanan ko lang onte what to expect, and kung gusto nyo na mag-advanced reading, good yon. Okay, para hindi kayo masabaw sa susunod na meeting. Okay, so to give you an idea, kapag weak acid strong base titration, what happens is that nagkakaroon tayo ng buffer systems. Okay, nagkakaroon tayo ng buffer. Why? Kasi when we neutralize the weak acid with a strong base, nagkakaroon tayo ng presence ng conjugate base and the acid. When you have the acid conjugate base pair, ano yon? Buffer yon. Okay? So that's why gagamit talaga tayong equilibrium equations dito kapag weak acid yung involved. Okay? Because of the presence of the buffer. Okay? So the initial pH for weak acid, we know that. That's square root of tsaka. Okay? So dapat gagamitan to ng equilibrium. However, sabi ko nga sa inyo, yung approach ko would be the simpler one. Okay? So we will use the small x approximation always. No? Unlike sa mapapanood nyo sa Khan Academy, sa Learn Organic Chemistry or Organic Chem Tutor, o kaya Professor Dave Explain. No? Pinapanood ko rin kasi yan eh. Okay. Pag naghahanap ako ng problem, minsan nanonood ako sa kanila. Kasi bibigay ko sa inyo. Di ba? Hindi kayo aware. Okay. Pero ganun na. Iba yung approach nila sa approach ko. Sila, they follow the equilibrium. However, in my case, to simplify things, we use the small x approximation Okay? So kung naalala nyo, small x approximation is the square root of tsaka. No? So yun. Para hindi na maging complicated lahat ng bagay. If you consult your textbook, ganun din, equilibrium. Pero in the end, pag gumamit ka ng small x approximation, ganun din naman sagot mo. Okay? So why to complicate? Why to complicate things, no? If pwede naman siya gawin simple. Kaya yan ha, again, that's a disclaimer. If you will look for other videos online, iba sila ng approach sa approach ko. Okay, kasi yung akin, simpler version. Okay. Yung sa iba, magugulat kayo. Promise. Magugulat kayo yung equation for H plus, makikita nyo yon as square root of Ka, K1, K2, plus something, something divided by something, something. Yun yung kapag equilibrium ginamit mo. However, I don't want to use that because it's so complicated. So, simplify natin yung mga bagay. Okay? So, again, what to expect next meeting? Expect that we will use buffer equations and other equilibrium equations because of the presence of the conjugate acid-base pair in the titration of weak acid and weak bases. Okay? So at initial, that's the square root of tsaka. At equivalence, at pre-equivalence, we will use the buffer. Okay, because we have the presence of the conjugate base and the acid. So buffer talaga yon. And at equivalence point, we have the conjugate base alone. So to solve for the POH, that's the square root of this times that. Discuss ko yan maigi next meeting. And at post-equivalence, you will have excess base, and that excess base will account for the pH of the solution. Okay? So, ayun lang. Kailangan nyo expect next meeting, may buffer system tayo. So, we will use the Henderson-Hasselbach equation. Okay? So, please recall the Henderson-Hasselbach equation. Ano pa? Ayan, yung curve natin, this will be slightly similar. Slightly similar kasi pagdating sa point na to, medyo magfa-flat siya dito. 'Di ba kanina pag slowly increasing, then inflection point. Pag buffer region may ganyan. Magi-increase then suddenly magfa-flat. Buffer zone 'yan. Okay, ibig sabihin the pH doesn't change drastically. However, if the buffer is destroyed, mag-equivalence point na tayo. Okay. So we will discuss more of this next meeting naman. Then yan na yung mga sagot. Kung gusto nyo aralin in advance, sige, go. Pero di-discuss ko pa yan carefully next meeting. And then, kapag weak base, strong acid naman, similar case, you have the base and the conjugate acid. So, you have the base here initially. When you add the acid, you will have the base and the conjugate acid pair. Ibig sabihin nun, may buffer region na naman tayo. So, kapag buffer region, you will use Henderson-Hasselbach equation. Okay. After ng buffer, pag nasira na yung buffer, equivalence point na yon. Okay. The species that will contribute to the pH is the conjugate acid. And ito yung equation na gagamitin mo doon. And then after equivalence point, the pH is the pH can be calculated by the amount of excess acid na lang. Or ito yung equation. Okay. So yun lang. Still same process. No? Alamin mo muna yung endpoint volume, then saka mo i-apply yung equation pag alam mo na yung stages. So, pwede nyo na to i-try in advance kasi binigay ko naman yung solution. Okay. Pero again, di-discuss ko siya maigi next meeting. Medyo marami pa tayong i-discuss. Pero kaya yan. Sa polyprotic pala, ito yung sinabi ko kanina na magugulat kayo. Kasi tignan nyo, ang daming nangyayari, bulaga. Tapos tignan nyo yung equations, ang dami. Sa ito, triprotic. Tapos tignan nyo yung equations, mas marami. Ay, asa na? Di ba maski iPad ko naglalag? Sobrang daming equation eh. Bulaga. Papagawin ko ba to sa inyo? Hindi. Okay. Papadaanan lang natin to next meeting. Okay. Kawawa na kayo pag pinasagot ko pa to sa inyo. Pero pinakita ko lang yung equations. Ito, ayan. Mas maraming equation ginagamit. And then, yun. Okay. So again, saka na yung mga last questions na yan. Okay, so anyway, again, sabihin ko lang ulit sa inyo, this topic is quite technical. It will involve the use of all your knowledge sa solutions and sa equilibrium. So if you do not understand the equilibrium, you will find this topic very hard. Pero if you understand the equilibrium, you will find this topic tolerable. Okay? So hindi na siya hard, tolerable na siya. Pero kapag master mo na yung dalawang yon, this is a very easy topic. Okay? So hopefully, dun tayo sa master na, no? Kasi kung ano-ano na pinagawa ko sa inyo sa equilibrium. So I know mauumay din kayo dito, may expert nyo rin to, no? And mataas din makukuha yung mga score. Okay? So again, ang concept lang naman nito ay umiikot dito sa apat na equation na to. Ayan, ito yung equation na buhay nitong topic na to. Okay? So as long as you know all this stuff and how to use them, there will be no problems. Okay? Sa ating topic. And again, if you have any questions, don't hesitate to ask me, no? Kasi I anticipate that, no? Kasi mahirap talaga tong topic na to, okay? For beginners, no? Pero I know magagaling kayo kaya kaya niyo yan, okay? So, pero again, pag may question, tanungin ako, don't hesitate to ask. And before I end the session, para kumain na tayo kasi nagugutom na rin ako. So, please watch this video na lang, ha? Ayan. So, this is the link, yuutu.be/yan. Okay. So, this is the video I showed earlier na hindi nyo narinig kasi mahina yung audio. Okay. So, yun. Panoorin nyo na lang to. Okay. So, this is about the steps in doing titration process. Okay. Pasensya na kasi hindi tayo face-to-face eh. Pag face-to-face to, masaya to eh. Pero again, darating din tayo sa time na yan. Basta mag-ingat lang muna kayo. And hopefully, pag nag-face-to-face na, magkita-kita tayo sa FEU main. So, So, for now, that will be all for our discussion today. So, I hope you are safe always. If you have any problems, just let me know. Okay? Pag nagkasakit, sabihin din sa akin para mai-refer ko kayo sa UHS. No? So, mag-iingat parate kasi magkikita-kita pa tayo in the near future. Okay? So, sa mga pillars of strength dyan, stay safe parate. Okay? So, thank you for your attendance and that's all for today. So, kain na po tayo ng lunch. No? So, ingat and bye-bye. Okay. So, upload ko to sa YouTube ha. Kung gusto niyo mag-advance study, okay lang.